Bismillahirrahmanirrahim. Assalamu alaikum students. Today we will discuss another problem. This problem is related to the electric field due to an infinite sheet of charge and the principle of superposition. So let me write the problem, then we will discuss together the solution. The problem goes like this. Figure 1 shows portions of two large sheets of charge with uniform surface charge densities of sigma plus equal to plus 6.8 microcoulomb per meter square and sigma minus equal to minus 4.3 microcoulomb per meter square. Find the electric field E part A to the left of the sheets, to the left of the sheets, part B between the sheets, and part C to the right of the sheets. Let me draw the figure. Use another color here. So these are my two sheets. portions of two large sheets. Left one has positive surface charge density. The right one has negative surface charge density. This is my figure one. So before going to the solution, let me check the problem. The problem goes like this. Figure 1 shows portions of two large sheets of charge with uniform surface charge densities of sigma plus equals plus 6.8 microcoulomb per meter square and sigma minus equal minus 4.3 microcoulomb per meter square. Find the electric field. Part A to the left of the sheets, between the sheets part B, and part C to the right of the sheets. So we have to find electric field here to the left of the sheets. This is our part A. In part B, we have to find the electric field between the sheets, that is here. And in part C, we have to find electric field to the right of the sheets, that's here. So as you know, electric field at a point due to many charges is the vector sum of the individual fields. That is the principle of superposition principle. So we will find electric field due to positively charged sheet and negatively charged sheet. Then we will find electric field at point A, that is to the left of the sheets, between the sheets, and to the right of the sheets, making use of superposition principle. You know, if I have some infinite sheet of charge, for example, with positive surface charge density, and we are assuming this surface charge density is constant, it is given uniform surface charge density. That means over the sheets, charge density is constant. Now, you know, electric field due to an infinite sheet of charge is sigma by 2 epsilon naught. This is the expression for electric field due to an infinite sheet of charge, where sigma is the surface charge density in the sheet and epsilon naught is the permittivity of free space, and we are assuming the sheet is placed in vacuum. Electric field is outward perpendicular to the sheet. If the surface charge density is positive, it will be inward perpendicular to the sheet if the surface charge density is negative. Now, our sheets in the problem in question are not finite, but they are portions of large sheets, right? And we are seeing the electric field, since they are portions of the large sheets, for the point of observation to the left of the sheet and right of the sheet and between the sheets, they are effectively infinite sheets. I repeat, they are portions of large sheets of charge, so we can make use of the infinite sheet electric field expression, right? So our strategy in the solution is to deal with each sheet separately and then to add the resulting electric fields by using the superposition principle. Now for the positive sheet, The magnitude of the electric field due to the positive sheet is sigma plus by 2 epsilon naught, right? E plus is representing here electric field due to the positively charged sheet, which is left sheet, right? Which is positively charged. So let's put the numbers as 6.8 into 10 raised power minus 6 coulomb per meter square. Remember, the 6 microcoulomb per meter square, and 1 microcoulomb is 10 raised power minus 6 coulomb. So we have written 6.8 into 10 raised power minus 6 coulomb per meter square. Then I have here 2 times the epsilon naught, which is 8.85 times the 10 raised power minus 12 coulomb square per Newton meter square. 8.85 into 10 raised power minus 12 coulomb square per Newton meter square. When we do the calculation, it turns out to be 3.84 into 10 raised power 5 Newton per coulomb. So the electric field due to positively charged sheet or left sheet in the figure has magnitude 3.84 into 10 raised power 5 Newton per coulomb. As always, check the calculation at home, right? Now let us find the electric field magnitude due to negatively charged sheet or right sheet in the figure. So for the negative sheet, we have E minus represents the electric field due to negatively charged sheet, its magnitude. So we take the magnitude of the negative surface charge density over 2 epsilon naught. Let us put the numbers. It is 4.3 into 10 raised power minus 6 coulomb per meter square. Then I have 2. Then I have epsilon naught 8.85 into 10 raised power minus 12 coulomb square per Newton meter square. 4.3 into 10 raised power minus 6 coulomb per meter square is sigma negative. Then I have twice the epsilon naught, which is 8.85 into 10 raised power minus 12 coulomb square per Newton meter square. So we have used this value and use it 1 microcoulomb is 10 raised power minus 6 coulomb. So when we solve this, it turns out to be 2.43 into 10 raised power 5 Newton per coulomb. Check the calculation. At home. 2.43 into 10 raised power 5 Newton per coulomb. So let us show these fields in the figure. So E plus is away from the sheet. So E plus here will be oriented this way. This is my E plus. Here it will be oriented this way between the sheets. This is E plus, and here it will be oriented this way, right? So these vectors represent the electric field due to positively charged sheet. It is away from the sheet. Here, away from the sheet, away from the sheet, away from the sheet. Now let us show E negative vector with different color. Electric field due to negatively charged sheet is towards the negative sheet. So it is like this. This is E negative. Here it is towards the sheet. This is E negative. Here it is towards the sheet. This is E negative. So here to the left of the sheet, it is towards the sheet. Between the sheet, it is towards the sheet. To the right of the sheets, it is towards the sheet, right? And you can see I have shown E plus vector having larger length than E minus because the magnitude of E plus is larger. It is 3.84 into 10 to the power 5 Newton per coulomb, but the magnitude of E minus is 2.43 in 10 to the power 5 Newton per coulomb. And we know length of the vector is proportional to its magnitude, so E plus vector is longer, right? Now the resultant fields in these three regions follow from the superposition principle. So let us move. The resultant fields in these regions, three regions mentioned in the problem, three regions follow from the superposition principle. From the superposition principle. Right? Now to the left of the sheets, first we have to decide which direction we have to take the positive. So taking, let me specify that first, taking components of E in figure 1 be positive if E points to the right, and negative if E points to the left. So we take this our sign. So we take the components of E in figure 1, positive if E points to the right and negative if E points to the left. That means this is my positive direction for E, right? That means this is my negative direction for E, right? To the right positive, to the left negative. You can do the otherwise, but you have to accordingly interpret your results, right? So to the left of the sheets, therefore to the left of the sheets, we have, I will write it E left. It is minus E plus E minus. Understand this. To the left of the sheets, we have two fields. E plus is pointing in negative direction and E minus in positive direction. So we take those signs into consideration when we add them. So we have taken E plus as minus and E minus as plus in the sum, making use of superposition principle. Let us put the numbers. Minus E plus we have solved is 3.84 into 10 raised power 5 Newton per Coulomb plus 2.43 into 10 raised power 5 Newton per Coulomb minus 3.84 into 10 raised power 5 Newton per Coulomb plus 2.43 into 10 raised power 5 Newton per Coulomb. So you can see negative term is bigger, therefore the result will be negative. It will be minus 1.4 into 10 raised power 5 Newton per Coulomb, right? Minus 1.4 into 10 raised power 5 Newton per Coulomb. As always, check the calculation at home. So this is our answer for electric field to the left of the sheets. That is here. Since the result is negative, that means this field, let me use some other color, E left will be towards left, equal to the difference of E plus and E minus. This is EL in the figure. To the left, because negative and magnitude equal to difference of E plus and E minus, right? So this is our answer for part A. Now, to the right of the sheets, to the right of the sheets, the electric field has the same magnitude. As you can see, let me write it. We have to the right of the sheet E right, that is here. So we have to take now E plus as positive, because E plus to the right of the sheets is pointing towards in the positive direction. So let us do. So we'll have plus E plus minus E minus plus E plus because it is in positive direction minus E minus. Put the numbers plus E plus is 3.84 into 10 raised to power 5 Newton per Coulomb minus E minus is 2.43 into 10 raised to power 5 Newton per Coulomb. So the difference is the magnitude of E right is same as the magnitude of E left. That's 1.4 into 10 to the power 5 Newton per Coulomb, but it will be now positive. 1 plus 4 into 10 raised to the power 5 Newton per Coulomb plus 1.4 into 10 to the power 5 Newton per Coulomb. So we have solved for electric field to the right. So in the figure, this vector now will be in the positive direction. That means it will be, let me use some other color. In the figure, it will be this way. This will be E right, pointing in the longer vector, but magnitude equal to difference, right? Now, between the sheets, let me use another page. Between the sheets, we have E, I will write it between, is E plus plus E minus. Go to the figure. Between the sheets, both vectors are pointing in the positive x direction. So we have to, so positive direction chosen for E. So we have to add them both. We have to take positive. So let us put the numbers. It is E plus as 3.84 into 10 raised to the power 5 Newton per Coulomb plus 2.43 into 10 raised to the power 5 Newton per Coulomb, 3.84 into 10 raised to the power 5 plus 2.43 into 10 raised to the power 5. When you add them, it is 6.3 into 10 raised to the power 5 Newton per Coulomb. This is our E between or E center. Let me encircle it. 6.3 into 10 raised to the power 5 Newton per Coulomb. Since it is positive, it is pointing to the right in the positive direction of E, right? Check the calculation. So in the figure, E between is this way, longer vector to the right. Let me use some other color. I think this color. So E between is this way. This is E between to the right, having length equal to sum of these vectors. So we have solved our problem, right? Now one remark, you can see outside the sheets, that's to the left and to the right, outside the sheets, there is subtraction of individual fields, right? But between the fields, there is addition of the fields, individual fields. So outside the sheets, the sheets the electric field behaves like that due to a single sheet whose surface, I should have written it here. Okay, no issue. I missed the page. So I will write outside the sheets, the electric field behaves like that due to a single sheet whose surface charge density is sigma plus sigma minus or 2.5 into 10 raised power minus 6 coulomb per meter square. I'm saying outside the sheets, that is to the left of the sheets and to the right of the sheets, the electric field behaves like that due to a single sheet whose surface charge density is the sum of sigma plus and sigma minus, which turns out to be plus 2.5 into 10 raised power minus 6 coulomb per meter square. Think about this. Think about this and convince yourself at home. This is all for today. We have completed this problem. I hope you enjoyed solving this problem. Don't forget to like, share, and subscribe my channel. You can give comments in the comment box. Thank you. God bless you. Assalamu alaikum.